Hello everyone. Today we are going to see how to write the vector equation of a straight line. So for example, if we have the line y equals minus 2x plus 9, this line has a y-intercept 0, 9. It more or less looks like this. And the vector equation of a line is r equals a plus t d, where r is a vector from the origin to all the points of the line. So all the points are x, y. A is a vector from the origin to a particular point on the line. It can be any point, but a particular point. So let's say that a point here, for example, is the point 1, 7. Just plug 1 here, you get 7 for y. That means that this vector is the vector A, and that's the vector 1, 7. Then t is any real number, and the vector d is the vector that is parallel to the line. Now this line has slope minus 2. That means, for example, for one step to the right, that means 2 steps down. That means that this vector is the vector 1 minus 2. 1 to the right, 2 down. D is called the direction vector. Direction vector, and it has to be a vector parallel to the line. So here it's the vector 1 minus 2. D could be any vector parallel to the line. For example, 2 minus 4, minus 2, 4, minus 1, 2. Any vector that is parallel to the line. This equation is called the vector form of the line. That's the line given in the vector form. From the vector form we can obtain the parametric equations. So x equals 1 plus t times 1, so 1 plus t, and y equals 7 plus minus 2 times t, so 7 minus 2t. These are called the parametric equations of the line. Pay attention, from this equation we can obtain t as x minus 1. From this equation we can obtain t as y minus 7 over minus 2, and then since this is equal to 2 and this is equal to t, we can equal the right sides to each other. So x minus 1 is equal to y minus 7 over minus 2. Here I'm going to write over 1, since in reality here it is over 1. Pay attention that the 1 minus 2 are the same numbers as the coordinates of the direction vector. This is called the symmetric form of the line. This equation in reality, if you think about it, it's like y equals mx plus b. We just multiply by minus 2, so we get minus 2x plus 2 equals y minus 7, or y equals minus 2x plus 9, which is what we started with. So as you can see, this is the vector equation of the line. Pay attention that, for example, if t is 1, this is the vector d, and this is the vector r. In case t is 1. If t is 2, then this is the vector 2d, from here to here, 2d, and this is the vector r, in such a way that r is a vector that reaches all the points of the line depending on the value of t. There are infinite ways to describe these lines. For example, the same line could be here a point on the line. A point on the line could be, for example, the point 2, 5. If I plug 2 here, I get y5, so 2, 5, that's a point on the line. And here I could write any vector parallel to the vector 1 minus 2. For example, minus 2, 4. This is the same line, describes the same line as this equation. So from here you can see that x is equal to 2 minus 2k, y is equal to 5 plus 4k. From here you can see that k is equal to x minus 2 over minus 2. K is equal to y minus 5 over 4. Equaling the right sides, we get x minus 2 over minus 2 equals y minus 5 over 4. If I multiply by 4, I get minus 2x plus 4. equals to y minus 5, and as you can see again, y is equal to minus 2x plus 9, and that of course again is the same equation. So there are infinite ways to describe a straight line with the vector form.